Good morning to all. Today I explain about final year project. Our department is Mechanical and Automation Engineering. My topic is IOT using solar monitoring system. My team members is myself. My name is B.E Mechanical. He is B.E Rohit. He is Suradmani. B.E Rohit will continue the overview of the project.
Good morning. This is our project. Title is IoT based solar monitoring system. And this we are going to use solar panel, and it is a 9-volt solar panel. And for an output, we are going to use an LED light, and Arduino UNO board is also used. And for this, we are using an external battery for this, and a Wi-Fi dongle for a remote operating system, and a transformer because for reduction of current. If the current is overload, and it will reduce the current for an addictive current. And we are using an LED display for monitor a correct output because we are using a solar monitoring system because power is very important here. After the LED screen, we are using a booster converter, DC to DC, direct current to direct current, and an inverter. We are using an inverter for an output, and this battery, it is an external battery because the power which came from solar to the power will store in this battery, and from this battery we are going to take an output from this switchboard. Thank you. And the remaining things are going to be explained by our teammate, Mr. Solomoni. Mr. Please carry on.
Thank you, Rohit. Now my teammate has shared some of the overview of the project. Now I am going to explain briefly my project. So this is a solar panel of 9 volt. From this, now we are going to get the power source of 9 volt to the Wi-Fi divider circuit. This is the Wi-Fi divider circuit. We are using the divider circuit for when over voltage will be come from the power solar panel. It will divide the external voltage. Then it move to the voltage to this inductor. So the inductor will use this for the, this is not inductor but it is a transformer. So the transformer, in this transformer we are using the one side of the part to convert as a inductor. So the inductor, you all know that the inductor will cut the over voltage of the input. So here we are using the inductor to store a power of 12 volt in this battery. So now the input which is coming from the solar panel is moved to the base booster of its 12 volt base booster. We are using that 12 volt base booster to convert the 9 volt which is coming from the solar panel into the input to the base booster. It will convert to the 12 volt to store in this output battery. Because the battery source is 12 volt, so we are using the inverter to run the 12 volt battery to get the output of current sources. So here we are using some display of 6x2 LCD. So this is for a virtual display which is showing the output of solar panels reading of how the sunlight, how was the temperature of the sunlight is intimating in the solar panel. And this is the one of temperature sensor and humidity sensor which is used for show the temperature of sunlight, and the humidity sensor which is used for if there is any water drops in the solar panel, so it will indicate to the display. And we are using the Wi-Fi node which is used to show the output, which is used to show the output within the which is used in IoT or like a mobile or laptops or any other electronics item which is using by the internet. We can take the output in any over of places out from this project itself. So we can get the output from any other places. So this is a brief explanation about the project. And this slide is to show the output of inverter, how the battery is storing the internal sources by the 12 volt, 9 volt to 12 volt, and how the light sources convert, how the inverter is producing a power to output like as light. Now I am going to show how my project is running.
And actually, first of all, this is our output of our project. and you can see the solar panels power and voltage is 110, and temperature and humidity. Because of we are using an humidity sensor, the temperature is currently the temperature is 29 and the humidity is 65, and in this the output, we are going to see the output now. And from this battery, from the power which I have gained from the solar panel and which is came into this battery, and this is an electrical output, actual electrical output of this project. And finally, because we are using an Wi-Fi dongle to monitor this from remotely, and you can see here we have connected this dongle to our mobile phone, and you can see the content which are showing in the LCD screen. You can monitor remotely. I will show you. First of all, we should go to a Blink application which have connected to this project, and here you can see the actual value of our output will be displayed here in this application. Actually, the solar power is 900 and the voltage is 110 and the temperature is 29, which are actually showing in the application. And the humidity is 65. And you can see the current action of the process in the application also. And thank you for taking the time to see our presentation, and thank you for your valuable time. Thank you for watching this video.